Welcome back. In this video, we will explore more about vectors. I'll be explaining how we can find magnitude of a vector, its direction, which is usually specified using unit vectors. And also we'll see some part of vector algebra, that is vector addition, multiplication, which includes dot and cross products. Okay. So let me take an example. Before I directly jump to the simulation part, I'll take an example and show how these are done mathematically. Okay. So I'll consider two vectors, vector A, which is 3, 2, 1. The x, y, z values of vector A is 3, 2, 1. And the x, y, z values of vector B, let me take it as maybe 1, -2, and 2. You are already familiar how to represent any given point or a vector in Cartesian system, right? So if I have to actually write vector A, it is written like this. And in Cartesian system, it will look like 3ax plus 2ay plus 1 into az. Similarly, your B will be 1ax minus 2ay plus 2az. How you represent any vector uh, theoretically using expression, using the Cartesian system, Cartesian coordinate system, right? So now let me just consider the vector A. And if I want to find the magnitude of this vector, any vector you're trying to find magnitude, it is represented by this symbol. Okay. So how do we calculate magnitude of any vector? It is equal to square root of the sum of squares of the three dimensions. So if you consider the A value, its three axis values are 3, 2, and 1. So it will be equal to square root of 3 square plus 2 square plus 1 square. Okay. So that's nothing but root of 3 square is 9 plus 4 plus 1. So it is going to be root 14. So this is the magnitude of vector A. Similarly, you can find magnitude of vector B, which will be square root of the first number is 1, 1 square plus the second number is minus 2 square plus 2 square. You just have to take the squares of these points and add them under root. Okay, so this answer will be minus 2 whole square is going to be plus 4 only. So 4 plus 4 plus 1, which is 9, or I can say it is 3. So magnitude of vector A will be root 14 and magnitude of vector B will be 3. This is how you calculate magnitude of any vector. Okay. Now coming to the second part, I want to know the direction. Direction of any vector is specified by its unit vector, that is called A for the first one. Okay, so we call it as unit vector, or I can also write it as AN. So how do we actually find this unit vector? So unit vector is calculated as the vector A divided by its magnitude. Okay, so your vector A by its magnitude. Your vector A in formula, it is written like this: 3ax plus 2ay plus az. Whole thing divided by, just now you calculate the magnitude as root 14 for A. It is nothing but now split the denominator. So it will be 3 by root 14 into ax plus 2 by root 14 ay plus 1 by root 14 az. This is your unit vector. Looking at this, we'll be able to say the direction. It gives you the direction of the vector. Okay. So these are the magnitude and direction part. Now coming to the vector algebra, that is I want to add the two vectors. So if I want to do vector addition of two vectors, that is A plus B. So I just have to A plus B. Okay, so it's a one-to-one addition, axis by axis addition. That is, you have to add same axis values. AX values with AX, AY values with AY, AZ values with AZ. So for our problem that we have considered, the result is going to be, it is 3AX plus 4AX, 3AX plus AX, which gives me 4AX. Next is plus 2AY minus 2AY, it gets cancelled, 0. There is no AY component in the result. Then you have plus AZ and plus 2AZ, so total 3AZ. This will be the addition result. Okay. Similarly, if you want to subtract, you want to do vector subtraction. How do we write it as A minus B, which is same as A plus of minus B. You just have to reverse your vector B and add it to the vector A. So now if I subtract it directly, the answer is going to be 3 minus 1, so it is 2ax. Then you have a plus 2 minus of minus 2. 2 minus of minus 2. So I'll get plus 4ay. Subtract the 2, a minus b. Then you have az minus 2az. So it is minus az. This will be the subtraction result. Okay. You might have learned in the lower semesters the concept of parallelogram. If I have vector A and B like this, vector A and vector B like this, then you will be extending the lines parallel to the opposite lines, right? The resultant is going to be the diagonal of this. This is your resultant, which is A plus B. Now, if I want to do A minus B, your A is here, your B is here, minus B is exact opposite to B. This is minus B. Now you extend, do the normal addition between A and minus B. This will be your result vector, which is A minus B. This is how you usually do using the parallelogram law. Okay. Same thing can be done using simulation also. So this is about addition and subtraction. The third operation you can do on vectors is the multiplication. Okay. But when I say vector multiplication, I have two types of multiplication here. One is called as dot product, which is also called scalar product. Other one is called as cross product. Okay. Or it is also called as vector product. So two types of multiplications are possible, scalar and vector. So dot product is represented as A dot B, whereas cross product will be written as A cross B. Okay, so when you multiply A and B, there is a rule you have to follow for dot product. You should remember that same axis unit vectors, if I multiply, the answer is 1. That is x with x, ay with ay, or az with az is 1. But if I try to take the product between different axis unit vectors, the answer will be 0. Okay, for az, ax. Any opposite axis product which you try to take will be 0. Same axis unit vectors, if you multiply, the answer is going to be 1. So based on this, if I try to find the answer for the first question, it will become a element by element multiplication. Okay, I have 3, 2, 1, and the other side I have 1, minus 2, and 2 for B. So when I take dot product, only the same element components get multiplied. So you have this 3ax, 2ay, and az. Dot product with ax minus 2ay plus 2az. So when you multiply only the same components. 3ax into ax. So 3ax into ax is 1. So I'll get the answer as 3. Next, 2ay into minus 2ay. So ay dot ay is 1. So I'll only get the answer as 2 into minus 2, which will be minus 4. Then again 1 into 2, 2. So your answer should be 3 plus 2 minus 4. Your answer is 1. Now you understand why I'm calling this a scalar product, because when you multiply two vectors, you are getting the result as scalar. You multiplied vectors, but you're getting the answer which is a magnitude only, no direction. There is no a component in your answer. So it is a scalar. Okay. Similarly, if I have to talk about cross product, there's a rule for cross product also. Here, same axis values, if you do cross product, it is going to be 0. Okay. If you take same axis cross product, it is going to be 0. Whereas when you try to take cross product between different axis values, there is a pattern you have to follow. I'll take clockwise x, y, and z. Okay, like this. If I take cross product of ax cross ay, the answer will be az. If I try to find cross product of ay and az, the answer is ax. If I try to find cross product of z and x, the answer will be y. You can see that there is a pattern, right? X and y cross product, the third variable z will be the answer. If you take y and z, x. If you take z and x, y. Same thing if I take in reverse order. I have same values, but now I'm taking in anti-clockwise. Instead of x, y, z, I'm going in the reverse, anti-clockwise. X and z, again it is y only, but negative direction. Z and y, what is remaining? Which variable is not there? X, but negative direction. If I go in reverse order, y and x, z is not there, but negative. Okay, this is clockwise, and this is anti-clockwise. Okay, so and when you take now, if you take to try to take the cross product, you are going to end up with a vector value, not a scalar value. You will be having ax, ay, az values there. Okay, so that you can try it out. For the given values, you can try to find the cross product. It will be 3ax plus 2ay plus az, cross product with ax minus 2ay plus 2az. Ax is 0. You cannot do that, but ax with ay you can do. So it is 3 into minus 2 minus 6. When you do x cross y, it is this one. X cross y means answer should be z. Next, x with z. If I go in reverse direction, first x then z, first x then z, then answer is minus ay. Minus 3 into 2, 6 ay. Okay. Similarly, next you multiply the second term with all the three. So second term, if I multiply with the first one, 2 into 1, I'll get 2. Whereas it is y cross z, y cross x, ay cross ax. If I'm starting with ay and then going to ax, it is this one, which will be minus az. Okay. Then ay cross ay is 0. Next I have ay cross az, that is 2 into 2, 4. Ay cross az will be here. First is a. First is ay and then az. So your answer will be 4x, 4ax. Similarly, you can do for the last one. Okay. So if you see, your result is going to be a vector quantity which has magnitude as well as z components, the unit vectors direction. Okay. That's why we call it as vector product. So now the same thing, you have now understood the theoretical part. We'll try to simulate and get the result in the simulation. Okay. Here. So here, as you can see, we have in the previous lecture, we have defined single point and converted it to vector. So we'll be doing the same thing now, but instead of single point, we'll be using 2 points, 2 vectors. So let me type the first vector A, which is 3, 2, 1. Sorry. Okay. So you see the point is created here, point A. Second point is I've taken 1, minus 2, 2. So second point is somewhere here, B, if you can see. Okay. Now I want to convert both of them into vectors. So this is one way in which you can convert them into vector. You don't have to specify the starting point. When you don't specify the starting point, automatically it takes the beginning as origin and it draws a line from origin to that particular point. Okay. So I'll be doing same for both of them. Vector of B. I've converted both the points into vectors now. You see there are 2 vector lines in the direction specified. Okay. The next step is we have defined both the vectors. The first thing I calculated from here is the magnitude. To find the magnitude of any given vector, the command or the instruction for that, the inbuilt function for that is called length. You can see here length. Okay, length of the object. The object here is nothing but the vector for which you want to find magnitude. So vector of A is now assigned to new variable small u. Okay, please don't write length of capital A. It is length of u. After you have converted to vector, you should take the length of that particular object. Okay, so it is length of u. You see, you've got 3.74. If you just calculate and check what is root 14. Root 14 is nothing but 3.74. Okay, so what we verify here? Root 14 is 3.74. So you're getting the length of U as 3.74. The second parameter that we want, similarly, if you want, you can find length of the second vector also. Length of the object. The second vector is now V. It is in V. Okay. Second vector, you have got the answer as 3. You can see we got 3 for the second one. Okay. The next point is we need to find unit vector for the first one, the direction of the first vector, right? So for the direction, you have to now calculate it. You have a built-in function also, but we'll try to use this formula. We'll use this formula to find out the unit vector. Okay. According to the formula, let me just write it as UV variable unit vector. Okay. It is equal to it is vector U divided by, where is the magnitude stored? Your magnitude of vector U is stored in A. Vector divided by its magnitude, that is a formula, correct? So you have got U by A. It gives you the values of X, Y, and Z. So if you just, you can just try this. Open your calculator and check what is 3 divided by root 14. Okay, 3 divided by root 14 will be 0.801. You're getting 0.8 here. Okay, similarly, if you want 2 divided by root 14, the second value, it is 0.5345. It gives you 2 decimal place values. Similarly, you can check for the last one, 1 by root 14. Okay, so you have got the direction of the first vector, and you can see on this, you just try to zoom it a little. Can you see that there is one more arrow now being displayed on the vector A line? This second arrow shows me the direction in which your vector A is moving. Okay, you got this because you have tried to find out the unit vector. I'll tell you one more direct way to find out unit vector. Instead of doing the calculation, taking the division, you can directly use the inbuilt function called unit vector. Okay, you can use this unit vector of vector U. You get the same answer. Either you can use this method, formula directly, or you can use the inbuilt function. So both of them give you the unit vectors of the vector A. Okay, so I hope till here it is clear. Now coming to the next part, that is we are supposed to find the addition of two vectors A and B. And I want to verify whether the answer is same as what we have got in theoretical calculation. Right, so we'll try to find the resultant of the two vectors A and B. So let's say A plus B. Okay, so I've done A plus B. Is the answer correct? We got the answer. When I did A plus B, I got 4AX. AY component is not there, which means it is 0, then 3AZ. So if I convert this into points, it will be 4, 0, 3. I'm getting the same answer here. 4, 0, and addition of the two vectors will be 4, 0, 3. If you want, you can convert this into vector and plot it there. Okay, for that you just have to do vector of A plus B, right? So if you can see, your result has appeared here, that is vector C has appeared here. Does it not look similar to this diagram? The result is nothing but the diagonal of the parallelogram you will be drawing between A and B. It is exactly the resultant here. Okay. So this is about addition. Same way you can do subtraction also. You can convert, if you can find vector of A minus B. Right? You got this vector here. It is in opposite direction. It looks like this diagram, the second one, right? It looks like the second diagram. So you're done with the vector addition. Next, we need to find dot product. Okay. See, one thing is how I can map this to electromagnetics. In electromagnetics, your field, E field or your force, sometimes what happens, you'll have to combine the E and forces through vector addition. See, you'll be having multiple charges in a system. It is not just one charge you're trying to find the force for. You will have two charges between which you are trying to find force, or you can have multiple charges and you want to know what is the effect of all these charges together on some single point, right? So in that case, what you have to do, you have to find force that is being applied by each one of them and add all those forces together, right? So that's when vector addition comes into picture. Okay, you want to add multiple force values so that you can get a picture of how all the forces put together are acting on the test point or on the destination. Okay, and that this is the foundation of superposition theorem. Okay, now coming to the next concept, that is dot product. As I told you, dot product is nothing but it's going to give you a scalar result. When you multiply the two vectors, only the same axis values get multiplied and the opposite axis values or the other axis values will be 0. So I want to find, and I should be able to get this result. The answer should be 1 when I perform dot product, right? So to find dot product, you have a built-in function called dot. Dot product between A and B. You see, the answer is 1. Okay, so dot product between A and B is 1. That is what we got here in the solution, right? Now coming to the last one, that is vector. And yeah, the significance of dot product is that it measures alignment between vectors. Okay, it gives you the alignment between vectors. It tells me if the result, if I get the dot product as 0, it tells me that the two vectors are perpendicular to each other. Okay, I'll just give you the formula here. If you see, it is actually given as magnitude of A into magnitude of B into cos theta. It tells me the alignment of the two vectors, A, B, and the angle between them. Okay, if this angle is 0 degree, it means cos 0 is 1. Okay, then it is going to be exact, like both the vectors will be on the same direction. They'll be on each other. Okay, but if the angle is 90 degree, it becomes like this. And cos 90 is 0. It means that both of them are perpendicular to each other. Okay, so there's a significance of dot product. And in electromagnetics, dot product appears in flux concept, electric flux and power calculations. Okay, coming to the last one, that is cross product. You have a direct built-in command for this cross of A comma B. So you just have to complete this problem. You'll be able to get the result, which will be exactly same as this. So it is 6ax minus 5ay minus 8az. Okay. So this is a cross product between A and B. And what does this cross product signify? It signifies, uh, you can say that it tells me the perpendicular nature of the two vectors. Okay. Let me try to plot the vector for this. Okay. So vector D, if you just try to see it in the 3D dimensional space, it will be perpendicular to both vectors A and B. It gives the perpendicular nature. It will be perpendicular to the B line as well as perpendicular to the A line. Okay. So it is very important in electromagnetics because when you talk about magnetic force and electromagnetic energy, you will be using cross products there, right? So that's it about vector algebra. What are the operations you can perform on these vectors, like addition, multiplication. Multiplication involves dot and cross products, how to find magnitude and unit vectors, right? So the basics are done here. Now we'll start in the next video. I'll be talking about